This is the NEET 2018 question. The problem is like this. The moment of force, when a force of this much at this place about this point is given by how much? That's the question that's being asked. First of all, we shall know what do you mean by moment of force. Remember that whenever there is a moment of is there, it means it is product of distance. Moment of force means product of distance with the force. R cross F because both are vectors. So that moment of force is also called actually torque. So he is asking you to find out torque. Torque is R bar cross F bar. So I have to find the cross product of two vectors. When F is clearly given for you, what is R is not given, rather initial position and final position is given for you. So to get R position vector, I shall find out the difference between the initial position and final position, delta R. Delta R could be traditionally written like R2 minus R1. That means this final position minus this initial position. But I found that that is not giving the right answer while we are solving this problem, right? I don't know. It's a bizarre way. I tried solving it. You can also try and identify. So here in this problem, delta R is treated like R1 minus R2, which will give you a right answer. R2 minus R1 is not giving a right answer, so I'm not taking it. But if both the answers are there, say for example in the options, then we shall prefer taking final position minus initial position. But anyway, as that is not available, I am taking initial position minus final position. So what is delta R? R2 minus R1 is, so R1 minus R2 is first vector 2, 0, 3. That means 2i cap plus 0j cap minus 3k cap minus R2 is this one, 2i minus 2j minus 2k. So when I simplify, 2i minus of minus 2i that is equal to 0i cap, 0j minus of minus 2j that is plus 2j minus 3k minus of minus 2k plus 2k that is minus kk. That is the position vector that we have. We have force vector given to you as 4i plus 5j minus 6k, and we have position vector. Thus we can find the cross product. That implies to get cross product, to find cross product, we can use determinant of 3 by 3 magnet, 3 by 3 matrix. Sorry. Here I have explained how do we do that in a cross product in detail in the vectors playlist. You can go through that. I'll briefly explain that how do we do that, right? So to find out that cross product, we have to take a determinant of 3 by 3 matrix. The first row will be IJK. The second row will be the components of that position vector, that is Rx, Ry, Rz. The third row will be the component of force vectors Fx, Fy, Fz. So let us substitute the data that's available for you to get the torque. That implies torque equal to, in the determinant, I, J, K. This is the position vector Rx, Ry, Rz. Rx is 0, Ry is 2, Rz equal to minus 1. This is the force vector Fx, Fy, Fz. 4, 5, minus 6. After writing determinant, how do you find its value is also interesting. How do we do that is, I have to take I cap of this one. and I shall avoid the row that it is there has to be eliminated. The column that I is there has to be eliminated. After eliminating these two, whatever is remaining, these are like A, B, C, D of a 2 by 2 matrix. See, this is A, this is B, this is C, this is D. Then I have to say A, D minus B, C. So how do I write that? Let's write that. AD means 2 into minus 6 minus BC means 5 into minus 1. Be careful, this is AD minus. This is there, that minus is there. That is of I cap. Be careful to understand that for J cap, I have to add a minus. Minus J cap of. Again, I have to follow the same. Eliminate the row that J has and the column that the J is there, these two. Whatever is remaining is A, B, C, D. Again, I have to say AD, AD minus BC. Let's do that. Let's write what is that happen. What that happens is then AD means 0 into minus 6 minus BC means 4 into minus 1. Yeah, that is of J cap. Again, plus K cap. Only for J there is a minus. Be careful. Again, when you say K cap, eliminate the row and the column that the K is there. What is remaining is A, B, C, D. AD minus BC has to be written. Let's write that. AD means 0 into 5 minus BC means 4 into 2. That's how we have to find the cross product. Be careful and identify that. So torque equal to 2 into minus 6. I of minus 12 minus 5 into minus 1 is plus 5. Minus J of, this is 0 into minus 6 is 0. Minus 4 into minus 1 equal to plus 4. Plus 4. Plus K of 0 into 5 equal to 0. Minus 4 into 2 equal to minus 8. That implies torque equal to minus 12 plus 5 means minus 7i minus 4j minus 8k. That's the option available for you. Minus 7i minus 4j minus 8k. That's the answer that is we have to take. That's how we have to find out the torque. So be careful in understanding what's the definition of torque or moment of force. Identify how do you find out the cross product of two vectors using the matrix determinant, and do that. And be careful. I want you to just check, in case I want you to check, if delta R is written like R2 minus R1, I will get that value as R2 minus R1 means this 2 minus 2, 0 I cap, minus 2 minus 0, minus 2j, minus 2j cap, minus 2 minus of minus 3 plus 1, that equal to plus 1k cap. Because this delta R is seriously different from this, because here you got a minus 2, but here you got a plus 2. Here you got a plus 1, you will get a minus 1. You will get a torque that is different, and there is no option available. So what we can say is, even if we have done wrong by taking this by chance in the examination, as no option is available, you have no choice other than turning back to this and solve again. That's what I want you to give as a word of caution. That's it. Thank you for watching.